Welcome to Brain Vision.
Okay, so this problem starts with, be helpful to draw a free body diagram, right? So here's the container of bananas. So there's the gravitational force of 40 newtons because it says that's the weight. And because this thing is, I assume it says, why won't this draw? It says it's sitting at rest. That means the normal force is also 40 newtons. Okay, so we're looking for questions about friction, right? So A says, if no horizontal force is applied to the box and the box is at rest, how large is the friction force acting on it? So if there's nothing pushing on the side, this thing is at rest, there's no net force. That means the frictional force has to be 0 because it's at rest. The forces have to be balanced, right? So if there's no force pushing to the right, there's got to be no force pushing to the left. Okay, so once we get to B, C, D, the rest of these, we need to figure out friction. And so to get friction, the frictional force is the coefficient of friction times the normal force. Okay, so there's two types. There's static friction and there's kinetic friction. So the static friction is when the thing is at rest. So the static frictional force is the coefficient of static friction times the normal force. So the coefficient of static friction is 0.4 and the normal force is 40. So that means the coefficient of static friction is going to be 16 newtons. And kinetic friction is the same thing. So the frictional force kinetic is mu sub k times normal force, which is mu sub k. The coefficient of kinetic friction is 0.2. Normal force is still 40. So that's 8 newtons. Okay, so now that we know these two frictional forces, we can solve for these other questions. So B says, what's the magnitude of the frictional force if the monkey applies a horizontal force of 6 newtons? So now he's pushing this way. I'm just picking that direction, 6 newtons. So looking at your static frictional force, you haven't applied enough, right? Static friction is how much force it takes to actually make this thing move. So if you haven't pushed 16 newtons yet, you haven't made that box break the bonds that are causing the static friction, right? So it's not going to go anywhere. So that means if he pushes 6 newtons, the frictional force is also going to be 6 newtons. So remember, static friction, the value for the frictional force, when you talk about static, it's less than or equal to mu Fn, right? So this number can be less than 16, but once it hits 16, it's going to take off. Okay, so let's look at C. What minimum force must the monkey apply to start the box in motion? Well, you need to apply a minimum of 16 newtons because that's the static frictional force, right? So the minimum has to be 16 newtons. That'll actually break the bonds and make the box go. Okay, D. What minimum horizontal force must the monkey apply to keep the box moving at a constant velocity? Okay, so now the box is already moving, right? So let me get rid of this. Box is moving, and we want to keep it moving at a constant velocity. Okay, so once the box is moving, kinetic friction takes over. So kinetic friction is 8 newtons. So that means that once the box is moving, there's going to be an 8 Newton kinetic friction force. So that means if you want to make this thing move at a constant speed means no net force, this one also has to be 8 newtons. So you need 8 newtons to push to balance the kinetic friction of 8 newtons. And then E, if the monkey applies a force of 18 newtons, what's the magnitude of the frictional force and the acceleration? Okay, so now the monkey's pushing, we know the frictional force still has to be 8 newtons because it's moving, right? So now the monkey is pushing 18 newtons. Okay, so now there's a net force. So let's start by figuring out the net force. So the net force is 18 minus 8, so that's 10 newtons. Okay, and we know acceleration is net force over mass. So the mass I can get from the weight, right? Because mass is Fg over G because the weight is mass times G. So if I want to solve for mass, I can divide by G. So the mass would be 40 divided by, I'm just going to use 10 instead of 9.8. So that means the mass is 4 kilograms. And we already said the net force was 10 newtons. So 10 newtons divided by the mass of 4 kilograms gives you 2.5 meters per second squared. That's your acceleration. And then what's the frictional force? Well, the frictional force is still the kinetic frictional force. So it's 8 newtons. So the frictional force is going to be 8 newtons.